Hello, my name is Jacob Williamson, and I'm with Source Allies. We are talking about Python decorators in technically speaking. So, what is a Python decorator? A Python decorator is simply put a function or callable that decorates or changes or even inspects a function and its result or really any attributes about it. So, for example, here, if we have a simple decorator, I'll name it decorator. I want this to be able to inspect or change a function. So I need to pass it the function. I'll call this a function. I'll say func or class. And we need it to return some func or class that is either changed, the same, or even inspected in some way. So the simplest decorator you can do is just returning the same function. How you might use this decorator if you have another function, say it's some complicated function, does something, it might return or update a complicated value. Here I'll simulate that with a very complicated string called complicated value. And the naive way that you might want to use this decorator is to simply reassign complicated function to be the value of what the decorator returns. So here we can see that the complicated function, this name, was defined up here. We are redefining it with the output of what decorator has. Currently, it doesn't do anything, so we would just expect when I call complicated function for it to not do anything differently. And I'll print the result of this just so we can see it. So over here in my terminal, I will print it, and we say, hey, some complicated value. Perfect. Well, this isn't super useful. As we can tell, we're not really doing anything with it. One of the easiest things you can do with it is record in some way that you've done something with it. Perhaps you have some functions list that you want to update. Maybe you're writing a REST API and you want to say, hey, my function, when I call this decorator, needs to be put in a list. Maybe it's a REST method. So we can do a global function list here just to get it in scope. And then in function list, we can add our function. So if we actually print this function list before and after we do our decorator, oh, and it blows up. Oh, sorry, not add, it's append. My bad. Let's try that again. We see that before it, we have an empty list, which makes sense. Afterwards, we have a complicated function in that list. And then we still return our complicated value. So that's in general how you could use a decorator. Python makes this a tad bit easier though. So we don't actually need to redefine for ourselves this complicated function. What we can instead do, which is functionally equivalent, put this up here just to show the point. We can instead, right above our function definition, write in decorator syntax our decorator. Now, this decorator is a function up here, and it will be called with the body of complicated function, and will reassign the complicated function name to be whatever the result of this is. Functionally, this is equivalent to what we've commented out down here, but it's a nice little syntactic shortcut that we can take. So if we rerun, we can see the same thing happens. We printed our function list, which was empty. We decorated with this function list. We've added to it with our decorator up here. And when we print out down here, we have something that is now in our function list. So that's one of the simplest things you can do with a decorator. Decorators start getting more powerful, though, when you actually want to inspect the result of the function. So let's say we don't want to do this anymore. Maybe that's not what we want to do, but instead we want to log something about it. So let's say we want to print the result of the class when I have this decorator, or print the actual output. So instead of printing it here, maybe this complicated function runs in some critical or necessary loop in our application, but it might take a while. And we don't want to update this code because it might do something really complicated and we don't understand it. Or maybe we don't even have access to it. But we want to decorate it in some way to print the actual result. What we can do is in here, we can't just call func or class because this will happen when this decorator is resolved. So when Python actually reads this file, this function will resolve the result of decorator given this function body. So we need to wait. And how we wait is we simply create a wrapper function around it. Here, I will give it splat args and splat quargs. That is just a shorthand to say, hey, give me everything that this function would be invoked with, and I'm not going to care about it. I'm just going to take it all. So I don't care about the API of the function. I will then call the function with those arguments and keyword arguments that we said, hey, just give me all of them. Simple straight pass through. We can then print the result, and then we can return it. So this is a better function that we want, right? We want this wrapper to run so it runs the original function, prints the result, and then returns the result here. In order to do that, we need the decorator to return this wrapper function instead of the original. So we've actually just completely replaced this funker class with another function entirely. And so we can see here, when we run this, it should print out the result of complicated function, even though I haven't declared down here that I'm printing out this result. So if we go over here and run it, we printed out complicated value. And just to prove that it doesn't matter what this API is, maybe this complicated value requires some input to it. It depends heavily on it. So I want to just print out the integer as well. I've changed only this function, and I have not updated the decorator at all. And when I run it, it blows up spectacularly. Oh, because I didn't update the call site. Yes, we do need to give it an actual integer that it relies on. There we go. And then we run it. It prints out complicated value for us, and we did not need to touch the decorator at all. We simply needed to update the function definition for our new integer and the call site. So that's great, but there's one problem. I don't necessarily want to use print here. I might, in some cases, want to use print, but in others, I might want to use a logging library. Let's say logging. What it would be really nice to do is if I could pass something here to this decorator to be like, okay, I want you to use logging.error. And I use logging.error here because I don't have to set up anything to get it to show. So you might use info, you might use a different logging library altogether. This one is, for the sake of brevity, simple since it's already in Python. So I want to pass this here, but if we do it this way, you'll notice that the function or class that we're passing is logging.error. We don't want to decorate this class, we want to use this as a parameter. So instead of print, we want some parameter logger here. But the way decorators are used, you can only pass in one function or a class. That's going to be this, the body of this. So we need one more layer to get it to work properly. And we'll call this log result because that's sort of what it's doing. And we'll have it take a logger, some logger definition we care about. And then we'll define our decorator inside this scope. So it will have access to logger, and we can use logger here as the result. So this could be anything. This could be print, this could be logging.error, this could be a completely different thing that we want to send to perhaps Kibana, Log Central, CloudWatch, Datadog, anything really. And then remember, since we are adding a layer, we need to add one more return statement. So quick change here. We now have a log result decorator that takes in a logging.error. This will be called, and at interpretation time of the file, it will be called and resolved to this wrapped or this local version of decorator with logger in here. We will call this decorator that we've created, decorator here, we will call it with the function or class that we're decorating. In this case, it's going to be this body, the complicated function. And it will return a wrapper here that will essentially log what we want, the result from it. So ultimately, if we do that, we should see, when we run it, we have now got a slightly different message. The default for error.logging is to show this error root. And so we are now logging our complicated value of 56 in a specific logging library. And we can continue on this way with different decorators. Maybe I have multiple requirements that I also need to print it out. When I just add that, I don't need to change anything about the function. I don't need to change anything about the decorator. I just need to add it again. If I run it this time, we can see it both prints it to standard out and it logs it to our logging utility, which in this case also goes to standard out. It is important to note here that the order that these get resolved in is reverse of what you might expect. We can see here that top down in the file as it gets resolved, or it looks like it would get resolved in the order of logging error first and then print. But it actually gets resolved in the reverse order, starting from the definition. It resolves this definition, it will resolve log result of print, and then it will do log result of logging.error. Recall earlier, I said that a decorator is functionally equivalent to doing this. Complicated function equals the result of this decorator given complicated function. It's the same thing with multiple decorators. So here, it will be resolved in this order. And we can prove that by commenting these out and rerunning. They came back in the same order, print, and then the log statement.
And just for completeness sake, if I reverse these,
you can see that they are reversed here, which is different from what they were in the decorator right here. And that's really all a decorator is. The actual functionality of it is yours to decide, whatever this wrapper does. You can go up to 3 levels to get maximum efficiency and usage out of it. Going more levels doesn't hurt you necessarily, but it doesn't help you. You've really gotten 90% of the use of a decorator out of these 3 levels that you can use. And hopefully this helps you clean up your code, provide some generic utilities for said code, maybe logging results as we've done here. It's great for that cross-cutting concern. And otherwise, a lot of different libraries use it. So I hope this has been helpful. I've been Jacob. with Source Allies, technically speaking. Thanks.